A very good day to everyone. We are Group 26 from University Malaysia Perlis, and today we will be presenting our integrated design project titled Smart Camshaft Ventilator. This project was guided by our mentor Dr. Azizhaira binti Azizan, and this group is led by myself, Shiwan Raj Analaki G. Murugan, and includes member Nur Shafika Izzati, Tengku Faisal Sani, Muhammad Anik Alimi, and Yapchi Chuan. Our project Smart Camshaft Ventilator is designed to be a low-cost, portable, and automated breathing support system. It works by using a camshaft follow mechanism powered by a DC motor to press the ambu back. This replaces the need for manual effort, especially in emergency or low resources areas. The diaphragm movement is carefully synchronized to mimic a human's natural breathing pattern. Our goal is to create a reliable ventilator that can help save lives in rural clinics, ambulances, and disaster zones. There are five key parts that makes our ventilator works. The mechanical section moves the shaft up and down to press the ambu back. Then the compression part helps with the airflow, acting like a basic lungs. Power comes from either a DC source or a solar panel, make it usable even in place without electricity. For control, we use an IoT system that sends data to our phone app. And finally, the whole setup is protected in a frame to keep it safe, clean, and hygienic. In this project, we applied key elements of Industrial Revolution 4.0 to make the ventilator smart and efficient. We use sensors and mechanical system together, forming a cyber physical system. The ventilator connects to the internet for wireless data monitoring through the ESP32 and mobile app. With cloud connectivity, we can track real-time status remotely. And lastly, the system can make small decisions on its own, like adjusting the breathe rate with the embedded intelligence. The problems we identify is the lack of affordable and portable ventilators, especially in rural or emergency settings. Many existing ventilators are expensive, require stable electricity, and are not suitable in off-grid areas. Also, manually using ambu bags for a longer period is tiring and not practical. This shows that urgent need of a smart ventilator that is cost-effective, energy efficient, and easy to use in any location. This chart supports our problem statement by showing the common issue with current ventilators based on our survey. More than half of the respondents said ventilators are too expensive. Others highlighted problems like needing stable electricity, being too bulky, or requiring professional operations. Some also mentioned in the lack of modern features like IoT and alarms. This proves that need for a more affordable, portable, and a smart solution just like the one we are proposing. Four main problems were identified through research and surveys. First, ventilator shortages still occur in emergencies, especially in rural areas. Second, most machine is really heavily on stable electricity, which isn't always available. Third, manually operating ambu bags is tiring and not reliable for longer periods. And finally, many low-cost ventilators lack digital monitoring, which affects patient safety. Our project is designed to solve all these issues in one integrated solution. Our main objective is to develop a low-cost and a portable ventilator that can be used in emergency and low resources settings. We aim to make the device lightweight, dual-powered with solar and DC, and easy to carry around. It should also automate ambu compression using a camshaft system while providing real-time monitoring through a mobile app. Overall, this design follows SMART principle. It is specific, measurable, achievable, relevant, and time-bound for fast and effective deployment.
I will start by showing how our product, the Smart Camshaft Ventilator, supports some of the United Nations Sustainable Development Goal of SDGs. First of the SDG 3, good beauty and well building. Our ventilator provide affordable breathing support, e.g. Emergency area when the normal ventilator may not be available. Next, the SDG 7, affordable and pure emergency. We use solar power so that the ventilator can work during power cut off in the places with no electricity. So for next one is SDG 9, industries, innovation, and infrastructures. Our ventilator uses low cost and local available, but this help provide smart, affordable ventilator device that can be made and repaired easy. Lastly is under SDG 11, sustainable, green city, and community. Our device can be used during national disaster of emergencies, helping to involve healthcare in critical. So let's looking at what is already available in the market. Manual ambu bag. Manual ambu bag are cheap, but they need someone to keep pressing them all the time, which can be very tired. Next is ICU ventilator. ICU ventilator are great for little care, but they are expensive. Need stable electric and cannot be moved easy. So next one is a device. For device like the BIBAT and transport ventilator. They are helpful but still cost a lot and don't offer much feasibility. So this is when our product coming in the camshaft, the smart camshaft ventilator in its low cost, portable, don't need construct human effort and have smart features like mobile monitoring. Now let's looking at what is already available in the market. Manual ambu bag. Manual ambu bag are cheap, but they need someone to keep pressing them all the time, which can be very tired. Next is ICU ventilator. Lastly, during the COVID-19 pandemic, many army groups around the world create a DIY validator to help the storage. So project like the MIT E-Rate of Open Notch uses the motto of simple medical to automate the almost back. So, but many of them don't have the features like monitoring, LOD of solar power. Our design built on their thoughts idea, but we added smart features like mobile as sensors to check voltage sync and solar charging. So it is more ready for real use in emergency area.
Figure 11 gives a detailed view of what features users want in a ventilator. The top priority was ease of use, which is 76.7% of respondents want a design that non-specialists can easily operate. Next, 73.3% want the unroll back to be automated, which reduce leakage and increase consistency. 68.3% of respondents said IoT monitoring is important, meaning they want the ventilator to be controllable via a smartphone app. Portability was again emphasized here with 40% rating as essential. There is also strong support for dual power sources, especially with solar backup for use in places without reliable electricity. Well, focus on the pricing expectation. Most of the respondents, which is 63.3%, agreed that the ideal price should be between RM 300 and RM 500 ringgit. This confirms that affordability is a key factor, and our project target cost fits well within this range. Figure 13 shows who the respondents think would benefit the most from this ventilator. 88.3% pointed to ambulance staff as the primary users. 70% also mentioned rural training and disaster management teams. This tells us that the ventilator needs to be mobile, durable, and effective in emergency settings. Figure 12 highlights the importance of solar backup. 81.7% of the participants said having a solar power option is important or very important. This supports our design decision to include a solar panel for reliable use in off-grid or disaster-affected areas. Customer requirement, we have 7 points, which is easy operability by non-specialist users to enhance its accessibility, thereby achieving SDG3, compact and portable design, to improve transportability, supporting SDG9, dual power source, which is DC plus solar system, to diminish and facilitate continuous functionality, SDG7, camshaft-driven and move-back automation to achieve lightweight, resilient, and recyclable components. IoT monitoring via mobile application to improve resource efficiency and foster digital sustainability. Affordable pricing, which is affordable pricing between RM 400 and RM 500 to minimize financial obstacles, supporting SDG9. Solar power backup, resilient in power failure to advance SDG7 while providing renewable energy. Free usability in ambulance, clinic, emergency tanks, and etc. to deliver essential healthcare in distant or emergency situations.
Today, I'll be presenting the role of the House of Quality in our project, which is Smart Camshaft Ventilator, a portable, low-cost ventilator designed for rural medical use. Okay, what is HOQ? HOQ, House of Quality, is a part of quality function deployment process. It helps us translate customer need into engineering specification. For our ventilator, it ensures that we meet user expectation like portability, affordability, and safety with appropriate technical feature. Okay, next, I will be continue with HOQ in our project. We first identify key customer requirements such as reliability and ease of use. Then we match them with technical requirements such as type of motor, material, and power source. We rated the relationship between them using value. There is 9 for strong, 3 for medium, and 1 for weak.
Hi everyone, so my name is Muhammad Ani Alimuddin Azhar. So I will present about the product design identification. For the smart camshaft ventilator, it's a low-cost and IoT-related emergency ventilation device designed to automatically compress and embow back using a camshaft mechanism. It is ideal for use for rural clinics, ambulance, disaster zones, and low resource area where conventional ventilators are unavailable or too expensive. The smart camshaft ventilator provides minimal human operation, respiratory support while monitoring health parameters like SpO2, heart rate, and temperature. Also, it can monitor by mobile apps. Its special features include dual power supply, which is DC battery and solar, a compact and modular design, and a very lightweight, built under 5 kg. The device is expected to meet high demand in Malaysia, with an estimated 1,000 plus unit per year, competing a product like manual embow labor intensive while traditional ventilator cost and bulky. Positioning the smart camshaft ventilator as a smart sustainability alternative, the targeting manufacturing cost is below 500 ringgit, with a selling price between 400 to 500 ringgit, and special rate for NGOs and government agency. It's deliver up to 8 hours of battery life, race rates of 12 to 10 BPM, and rapid response under 5 seconds. Designs for 1 to 2 years is used with recyclable material and modular component. It's meet ISO 80,000, 800,000, 80601, IEC 60601, and ROHS safety standard. And then for the production will be held in-house using 3D printing and CNC machining, with certificate supplies providing medical grade part. The project timeline includes title selection by week 2, prototyping by week 5, and final proposal submitting by week 10. A patent has been filed for its antimicrobial coating method, reinforcing the product's innovation and potential for wide-scale impact.